This video is about solving quadratics using the quadratic formula. The first thing I want to talk about with the quadratic formula is the discriminant. Now, before you even get into solving quadratics, you actually want to determine how many solutions you're going to have and the type of solutions. So it determines the number and type of roots. Again, roots are your x-intercepts, zeros, solutions. So we're actually going to determine how many times it crosses the x-axis and if it's going to be at a real rational, or if they're going to be at irrational numbers, or if they're not even going to cross at all. So we're going to focus on the value of the discriminant. The value of the discriminant is used from b squared minus 4ac. b squared minus 4ac. Whenever you determine this, every letter you're going to put in the number from the quadratic. So every time you do this, you're going to have parentheses squared minus 4 parentheses parentheses, because it's b squared minus 4ac. You're going to plug your numbers into there. You're going to need to know your a, b, and c. Now, if your b squared minus 4ac is positive and it is a perfect square. Perfect square is when you have 1 squared, 2 squared, 3 squared. It's going to be your 1, 4, 9, 25, 36, all the way up until you can't go any further. But it's just, if it's a perfect square, that's what's important about it. It's positive and a perfect square. That means that your quadratic is actually factorable. What that means is that you don't have to use the quadratic formula to solve it. You can actually factor the problem using MACAB, or difference of squares, or grouping. Okay? So if your discriminant b squared minus 4ac is a positive and also a perfect square, you can actually factor the problem. But if you still are going to use the quadratic formula, you will have, if it's positive and a perfect square, it means that you can take the square root of it. So you're going to actually end up with 2. And because it was factorable, you're going to end up having 2 real and rational. 2 real rational. Because you could have factored it. Because you'll have nice, clean answers. You can solve for them easily. 2 real rational. What that means about the graph is that it will cross the graph twice, but it'll actually cross them at nice, clean x-intercepts. So it might cross them at, let's say, 3, 0 and negative 2, 0. It'll cross them at nice, clean intercepts. For the next one, if b squared minus 4ac is a positive but is not a perfect square, so any other number, so 2, 3, 5, 7, 8, any of those, you will still have 2 answers because it's positive. If it's positive, you'll have 2 answers. So 2, they'll still be real because it's going to be positive. Because it's positive, you can take the square root of it. But since it's not going to be a perfect square, they will not be rational. They will be irrational. 2 real irrational. Because you cannot take the square root of 3 and get a nice clean answer from it. So that means that it will still cross the x-axis twice. So it'll still cross it twice, but your solutions will not be able to be written as fractions. So you might have a positive square root of 3 and a negative square root of 3. If b squared minus 4ac is equal to 0, if your discriminant is 0, that also means that your quadratic was factorable. Because if you think about it, 0 squared is still 0. So your quadratic is factorable. This is actually, when it was 0, you're actually only going to have one solution because the square root of 0 is 0. And if I were to add 0 or subtract 0, so if I had 5 plus 0 or 5 minus 0, I'd still get the same answer. So we're actually only going to have one solution. But I can take the square root of 0, so that's why it's going to be real. And anytime I add 0 to anything, my number is going to stay the same. So it will be 1 real rational. And whenever you have 1 real rational, that means that the quadratic actually bounces on the x-axis. bounces. Now, it'll be rational, so you might have it at 2 over 3 comma 0 because it bounces. If your b squared minus 4ac is less than 0, that means that it's a negative number. Okay, this is when it gets tricky because you cannot take the square root of a negative number. This is actually when it becomes imaginary. Now, you technically always have two solutions. Even this one, it says one real. It's because it happens twice, so you only have to write it once. But when you have a negative discriminant, you're going to have two imaginary. Now, imaginary cannot be rational or irrational. It's literally just two imaginary. You can't change it. What that means is that your quadratic will not cross the x-axis at all. So it'll be a parabola with your vertex above or below the above the x-axis and opening up, or below the x-axis and opening down. So it will never cross the x-axis. This is when you have imaginary. So the reason we do this is to know before we even start solving how many solutions we're going to have and how many times it's going to cross the x-axis. Because when we're using the quadratic formula, you need to know before you even finish it if you're going to be correct. So to solve by the quadratic formula, you're going to set the equation equal to 0, so you're going to have it in standard form. You're going to figure out your a, b, and c, and you're going to plug it into the formula, and then you're going to simplify if possible. Now, if we have an irrational solution, we want to round it to the nearest hundredth. So the quadratic formula, the actual quadratic formula is written as x equals. It's x equals because you're solving for a quadratic. That's why it's x equals. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, when I said all over, notice that my x is still alone because we're solving for x. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That all over is important because all of that has to be over 2a, except obviously the x, because x has to be alone. Now, the b squared minus 4ac is what we did for the discriminant. This is why you want to determine that. If it's positive, you can take the square root of a positive. You can take the square root of a positive. You can take the square root of 0. You cannot take the square root of a negative. That's why we have two imaginary. But when you're finding the discriminant, you do not use the square root symbol in it. You just find the value. And then determine if it is a positive or negative, determine if it is a perfect square or not, and determine if it is 0 or not. Then you can go straight from there into the quadratic formula, finishing it, or you could go back to factoring it if it was one of these two. You could have actually factored the problem if it was one of these. If it was this one, it actually factors to a perfect square trinomial. So I'm going to give two examples real quick, and then I'll do another video on more examples. So the first example is x squared minus 8x plus 15 equals 0. This is already in standard form, so we can go straight into our quadratic formula. We need to know what our a, b, and c are. A is equal to 1, b is equal to negative 8, and c is equal to 15. So I'm going to take the quadratic formula, and I'm going to write it out, but every letter I see I'm going to use parentheses, except for x, because that's what we're solving for. So we're going to have x equals, I have a negative, I have b, so I'm going to put parentheses, plus or minus the square root of b, parentheses, squared, minus 4a is parentheses, c is parentheses, all over 2a is parentheses. Now I'm going to plug the numbers into my parentheses. So it was b. I'm going to put the negative 8 inside this first set of parentheses. Then this next one is b again, so I'm going to put negative 8 in here. And the next one is A, so I'm going to put 1. Next parentheses is C, so I'm going to put the 15. And then we have 2A, so I'm going to put that 1 in there again. So to simplify this, I can use the calculator. I have x equals negative times negative 8 is a positive 8 plus or minus the square root of. Now I want to type that into my calculator. Again, that is the discriminant. We want to know what the discriminant is. So I have parentheses, negative 8, parentheses squared, minus 4, parentheses 1, close parentheses, parentheses 15, close parentheses. Now notice I did not put the square root because the discriminant, as it is up here, does not have the square root symbol on it. So I press enter, and I have 4. So what that means, right, so I go ahead and finish this out, is all over 2 times 1 is 2. Now before I finish this, that 4 is my discriminant. So I'm going to write a note over here. The discriminant is equal to 4. That is a positive number, so I look over here. It's positive. It's not 0, it's not negative, so I look at these two. Now, is 4 a perfect square or not a perfect square? 4 is a perfect square because it's 2 times 2, it gives us 4. So that means that we will have 2 real and rational solutions. That's what that tells us. So when we finish this, we should have x equals 2 nice clean numbers or fractions, and we should have no weird imaginary solutions. So if we're going to finish this, we're going to have x equals 8. We're going to have 2 solutions. How we set up the 2 solutions is one of them is going to be a plus, one of them is going to be a minus. So we're going to have 8 plus the square root of 4 all over 2. Then we're going to have x equals 8 minus the square root of 4 all over 2. So everything stays the same except we separate them with one with a plus sign in the middle and one with a minus sign in the middle. So what we're going to do is we're going to plug this into our calculator and solve. We're going to simplify it. So in my calculator, I'm going to put the numerator in first. I'm going to put 8 plus the square root of 4 and then press enter. Then I'm going to divide by 2. That's where that came from. Now my solution, since I divided by 2, is now x equals 5. So I have x equals 5. The second one, now if I have a newer calculator, I can actually do this all at once. So I've shown you how to do it separate. You put the numerator, enter, then you divide it by the denominator, enter, and you get your solution. Now if you have a newer calculator, if you press the alpha y equals, it actually you can put into as a fraction. So I'm going to do, in my fraction, I'm going to put everything in my numerator up top. So I have 8 minus the square root of 4. Then I need to go down to the denominator and then press 2. Then press enter. And it gives me 3. X equals 3. Now going back to here, our discriminant was 4. It told us that we should have 2 real rational. 5 and 3, we have 2 answers. 5 and 3 are both real, and they are both rational because they're nice, clean integers. They're whole numbers. You can write them as fractions. So we were correct in saying that we should have 2 real rational. That also means that it should cross the x-axis at these 2 coordinates, or at these 5, 0, and 3, 0. So we were right using our discriminant, and we can always check back to make sure our answer was correct. So then I can say, yes, I was right with my discriminant. On this next problem, you can see that it is not in standard form. It says 8x squared minus 2x equals 5. So to put it into standard form, we have to subtract the 5 over to the other side. So now it should become 8x squared minus 2x minus 5 is equal to 0. We're going to use quadratic formulas for this, so we're going to figure out our a, b, and c. So our a value is equal to a positive 8. Our b value is equal to a negative 2. And our c value is equal to a negative 5. Now doing the quadratic formula, again, I'm going to go back to the quadratic formula, and everywhere I see a letter, I'm going to put parentheses. So I have x equals negative, parentheses, plus or minus the square root of parentheses squared minus 4 parentheses parentheses. I'm going to extend my square root symbol all over 2 parentheses. Okay, so we have negative b, so we're going to put in the b value. I'm going to put in the b value of negative 2. Then we have the b squared, so I'm going to put in that negative 2 inside of that, minus 4a, so I'm going to put the 8c. I'm going to put that negative 5. And then we have divided all over 2a, so I'm going to put the 8 down at the bottom. So I'm going to simplify as much as I can. So I know that I can do these two parts on my own, but this one I want to put my calculator. So I have x equals negative times negative 2 is a positive 2, plus or minus the square root of. I'm going to find my discriminant by plugging that into my calculator. Just that inside the radical, so no radical, so parentheses, negative 2 parentheses squared, minus 4 parentheses, 8 parentheses, parentheses, negative 5, close parentheses. I'll press enter, and I get 164. So I put 164 right here, and it's all over, and 2 times 8 is 16. Now I want to talk about the discriminant. The discriminant is what we just got from our calculator, which was that 164. Now it is positive, so I'm going to come up here. It is positive. It's not 0, it's not negative, so I'm going to focus on these two. So I'm going to have 2 real. No matter what, I'm going to have 2 real. But is 164 a perfect square or not a perfect square? So real quick, I'm just going to check this. If I don't know my perfect squares, okay, you can always check it. So take the square root of 164. It's not a good number, so this is not a perfect square. So that means b squared is positive, but not a perfect square. So we're going to have 2 real irrational solutions. 2 real irrational. What that means is that we will round our answers to the nearest hundredth. So we're going to still put them into our calculator and still round to the nearest hundredth. So we'll have x equals 2 plus the square root of 164 all over 16. We'll also have x equals 2 minus the square root of 164 all over 16. Now, if you're taking a multiple choice exam and it has all of your answer choices left in radical format, but it's simplified, you can always get your answer in decimal format and then look at the answer choices and put all of those in decimal answers and see which ones match. So I'm going to put this first one in separate form so you can see how you can write that. So it's 2 plus the square root of 164. I'm going to press enter because that's my numerator. And then I'm going to divide by 16 and then press enter. And that's my answer. So we're going to round to the nearest hundredth. So we're going to say x is approximately, because it's not equals, approximately 0 and. Now that 5 will make the 2 go to a 3. We want to round to the nearest hundredth. So we have the 92, and then we have the 5 is the next one, so it becomes 93 hundredths. So 0 and 93 hundredths. I generally always put a 0 before my decimal so that I can see that that is in fact a decimal. So this is, x is approximately 93 hundredths. My second one, I'm going to actually show you for the newer type of calculators again. I'm going to do my alpha y equals. I'm going to do that first part to put in a fraction. I do 2 minus the square root of 164, and then I press down, then I put 16. Enter. Now this is not giving me a fraction because this is an irrational number. So I have 1, 2, but I have to look at the third number. The 5 will make that 7 go to an 8. So this is x is approximately negative 0 and 68 hundredths. 0 and 68 hundredths, so negative 68 hundredths. These are our two solutions. Now, we do have 2 answers. They are real because we did not take the square root of a negative, but they are irrational because we have decimals. So that means that when we did our discriminant was 164. It was not a perfect square, but it was positive. So we had 2 real irrational. And those are types of solutions we have. So that means that our discriminant was correct and that our answer should match our discriminant. So that means that we should be good on those. That was just 2 examples of the quadratic formula. In a later video, I will do some more examples of quadratic formula.